Anyways, I'm a machine learning engineer at Twitter, and today the talk that I'll be giving is about our management of our ML features in dynamic environments. And before I give a rundown of kind of what I'll be talking about, there's my LinkedIn link and my Twitter handle. Definitely follow me on Twitter. It's MaviSavvyDev. And yeah, I'll give my overview of what I'll talk about. So for this talk, what I mean by dynamic environments, as you see in the title, is we operate in a highly collaborative context. So this means a lot of things are mutable. The feature definitions might be changing. There's a lot of versioning. We revisit models over time, retrain, redevelop. So in that kind of very high activity setting, how do we manage our ML features such that things are organized, things are consistent, and our machine learning engineers can progress and move forward without worry? And yeah, this is almost an obligatory kind of slide at these kind of talks. I feel like at almost every single conference, despite having many different responses to this question is constantly posed over and over again. So I felt kind of obligated to give my take on this. What is a feature store? So is it a set of standards? Is it a framework? Is it metadata management? Are they databases? I think often it gets confused for actually like physical infrastructure. But as Twitter knows really well, in our 1.0 version of our feature store, we actually had it completely virtual. So we actually didn't own any physical infrastructure. We had virtual layers that were built on top of existing data stores, existing data management systems. So yeah, there's a lot of interpretation of what a feature store could be. And moving on to the next slide. How I like to approach this question is often thinking about it in terms of whether it's a composition of existing problems and existing solutions to those problems. Whenever I think about a new technological system, I like to consider whether parts of it have already been solved. Is it just a rebranding? Do we really have to solve something new? Or because it's a composition of existing problems, it's just a composition of those solutions. So if you look at the list here, here's often what feature stores are composed of. This definitely a data storage layer. There's often some sort of joining of data. There's metadata management, data processing, jobs management, workflow management, high-load data fetching. If you guys take a look at the bullet points in this list, a lot of these sound familiar. They're like solved problems. So is the feature store, this notion of a feature store, really a new thing? And even though by this perspective, it might seem to be the case, but I actually want to share how I would define different products and different systems, which is we shouldn't ask what is composed of, but rather what its goals are. And if its goals are unique and how we solve those goals are unique, then I would consider the feature store not just a rebranding, but an actual novel system. So here is what I think are the core tenets of a feature store. This is in order of priority. Number one, ensure consistency. The type of consistency that we're most familiar with is just offline, online data consistency. That is kind of like the fundamental foundation of consistency levels, but I'll talk soon about the different layers that I see in addition to that. Without consistency, no matter how fast you make the experimental flow, how fast you make productionization, the feature store can't be relied on. And at the end of the day, when the ML engineers move to the next steps of the process, do online experiments, wait for weeks or even months to get the results of those online experiments, those go to naught because the data was unreliable, the offline results don't translate to online, and at the end of the day, you wasted more time than if you had guaranteed consistency from the get-go, even if it slows down the process a tiny bit. But number two, I put increase experimental productionization velocity. So it is a crucial thing for this product to enhance the speed of experimental cycles, and how fast can you move those experimental components up to production. Number three, shareability of features. Self-explanatory there. So this is kind of how I define a feature store. So when you ask the question, what is a feature store? If whatever black box you have solves these goals, it's already 80% of the way there to being a feature store. But at the same time, I think the how question matters a lot. How do we solve these questions? For any kind of programming or product goal or any kind of technical functionality, one can use assembly language and code up any sort of program you want, but we don't want to interface with assembly. So I think the how matters a lot. You could also kind of do a messy combination of technologies that solve these to solve the problem. But again, that's not the kind of experience that people want. So to me, in thinking about a feature store, it's very important to be user-centric, to think about what the product needs to offer to the user, what's the user experience. So that's kind of what I'll go over real quick next. So here is what should a feature store be in the user's perspective, and this is from the consuming side. So we have the black box feature store abstraction. To me, a feature store should make it really simple to, on the offline side, join in features to existing data. So you just pass in some references to features and it joins that data in. And the user doesn't have to worry about time travel problem or time inconsistencies or where the data sources are, straight and simple. On the online serving side, same deal. You just have some feature references and you have some IDs, and we fetch the feature data for those IDs, and the user doesn't have to worry about consistency or any other details. They can trust the system. How about on the producing and registering feature side? So on this side, what's the goal of the user? What's the task the user is trying to complete? They want to offer up some data as features that their team and other team can use. And they want to make that data available as feature data. So for the producing side, or kind of associating that data with the feature store, I think the user just has to provide some information on where the data source is, maybe implement some interface to add some transform logic if the data needs to be transformed a little bit, set the schedule, and they're done with that. On the registering side, they provide the address of where the features are stored, maybe specify which features are included in that source, maybe some things about the structure of those features. That's not even necessary. Specify some metadata, and then you're done with that. Now, the main point here is not any specific kind of solution or interface that users should interact with to do these tasks, but the fact that the user experience should be, the user interaction with the feature store should be constrained and simple. So there shouldn't be any sense that, I'm not sure if I did this, would it actually work well on the consuming side? For instance, if we passed in, if we just kind of ingested any kind of data processing job jar and let it be completely open-ended, there are pros to that, but the con is, there could be potential incompatibilities for the way that that job stores the data in the feature store, or it gets interpreted by the feature store. So the user experience should be, hey, it's constrained. I know exactly what I need to give to the feature store, and I can have confidence that because I follow these constraints, the consuming side of the feature store will work well. And the last thing I'll say about this is that important step for a feature store is to validate that these inputs are correct and are up to the standards that have been set and structured. So I included, auto staging plus validation that it conforms to standard on this side for actually setting up the data job. And on this side, auto validation of source to ensure address exists and features exist to make sure the specified information on the registry side is also correct. So with that in mind, I don't think it's just a rebranding of existing tools and systems. Because the user doesn't have to worry about these details, the how of the matter, the how in accomplishing the goals is unique, it's novel, it's a different problem from what these individual items are trying to solve. Okay, so now I'm going to talk a bit more about these three components in depth. Number one, again, ensure consistency. So how do we do that? How do we think about this? Here's my consistency pyramid. So I kind of like to draw an analogy between this and like self-driving. So, in self-driving, there are different levels like L1, L2, L3, L4, L5. The way I like to think about consistency is in the same way. Like how consistent is your feature store? Is it L1 consistent? Is it L4 consistent? Here, there are only 4 levels. So like L4 consistent is what we strive to be. At the very foundation, and the more, the bigger the kind of base of the pyramid, the more important it is. So these higher levels are built off the lower levels. So at the base, we have consistency in data between offline and online stores. I think this is what people are most familiar with. This is just like, you have your data warehouse or data lake or whatever offline data store, and then you have your online store because the performance requirements are different. And is the data and the structure of those stores, are they consistent enough so that you can reliably get the same data? The second layer is consistency in feature definitions in a mutable shared registry. So this really ties in with the issues that are involved when you are operating in a highly collaborative environment. So if you have the property of shareability in your registry, a lot of teams are using your registry. How do you deal with the fact that you might be using a certain feature definition in a production system or in a recurring pipeline, but somebody else could change that definition because the registry is shared? How do you manage the rules and guidelines around not stepping on each other's toes there? The third layer is consistency in use of correct versions of sources and features. So here we have versioning is a really important thing in the ML space. And there can be a bunch of different feature versions, a bunch of versions for different pipelines. And how do we minimize the chance of human error when they choose their features to use, when they retrain things, when they reuse and revisit certain feature sets? So that's for that layer. And the last layer is the grouping of features tied to the model, which basically it's also a consistency level where we want to minimize the chance for human error, and that if you have a certain model and a model version, we want to be able to have the features used for that model be grouped together so that when this model is being developed by somebody else, being developed in the future, it's all tied together. So there's no chance of like, oh, I forgot to mention this feature, or I mentioned the wrong version of this feature. There's kind of a immutable structure that captures what was used for that model, and that will persist. So that's the consistency pyramid. And I'll go into some more details for each of these and how we kind of solve some of these issues. So for the first layer, consistency in data between offline and online stores, we're really gung-ho about really strict standards and structuring. And this is kind of how we really ensure the offline online data consistency. So on the left, this is a BQ BigQuery logo. We have very standardized schemas and structure in offline store. Everything that's fed into the store, it has to use a specific config template to define the job. The actual schemas of the table are very rigid. And then on the online store, we have the same sort of situation. And in the middle, these what we call materialization jobs that transfer data from the offline to online side, they're fixed by us. So you're not asking the customers or any user to write their own jobs to transfer this data. This is fixed. We do it for you. It's a standardized format. Because the two sides are standardized, we can do this reliably for different kinds of features. Consistency in feature definitions in a mutable shared registry. So again, this is the case where the store of feature definitions is shared between different teams. How do you make sure that the version that you saw, the version that you wanted to use, remains that way? And if that's the case, how do people add or include new features or edit features if they want to do so in confidence without fear of breaking something in some other team's code? So how we approach this is this problem isn't kind of a novel problem. This is kind of analogous to what Git tries to solve, and having a system for version control of code. And we take the same model and we actually use the same terminology too. So in the same way that in Git, there's origin master and there's branches, and anytime you want to kind of try something out, you make a branch from origin master, make whatever edits, use it for however long you want, and then share that code back in when you want to share it. We do the same thing with our registry. So we have an origin registry, and this is kind of like the production master registry. And give me a sec, this is sun's shining in my eye. Okay. And if you're somebody who wants to add some features, change some features, and make some modifications, you can pull out a branch, use it for however long you want. You can even use the branch registry as the basis of a production service. So you have like a copy that's yours, it won't change. And only when you want to push up your changes to the master production registry do you actually affect the origin registry. So in this setup, we think it'll work really well. We encourage people to take branch registries as far as they'd like. It's not only for like a sandbox playing around, but it's, again, if you had some production service and you register some features that you want to use, made modifications to the others, you can totally just have your production service be based on a branch registry and only push it up when you need to. And let's see. The last thing that I'll say about this is that our registry is also append only. So if somebody wants to change something or delete something in the origin registry, is a lot more complicated. We purposefully make it a friction process, and we purposefully insert a person in the middle where the person has to inspect the proposed deletion before it happens. Okay. Consistency and use of correct version of sources and features. So for this, I'll quickly go over this side. This is still a work in progress, so we're still figuring this out. But the gist of this is, should we give versioning first-class support, or can we kind of finagle it into our existing structures, like maybe the naming scheme or extra metadata fields? And the goal is to balance kind of performance, because this kind of affects how we structure our data and our data stores and databases versus reducing the chance of human error. Consistency in feature group tied to the model. So in this diagram, I'll first kind of explain what's going on here. These kind of spoke-like things are representing the models, and the lists are representing the kind of collection of features plus any associated parameters, any associated other config kind of information. And this is these people here are supposed to represent how this is highly collaborative, and the arrow suggests that this is being developed, retrained, reworked over time. So there could be cases where something was developed 5 months ago and a series of changes have been made to it, but you want to go back and like figure out, what did I do 5 months ago? That seemed to be going pretty well. And instead of having individual features that you reference, the set of features and any associated parameters are grouped together and are uniquely identified so that you can just refer back in the registry to that kind of, let's just call this a feature grouping, and know exactly on the feature side what went into the model. And it's just explicitly tied to a singular model. So this is really helpful when you're working with 2 other teams and they ask you, hey, what's the feature set you use? We want to take a look. Instead of saying, hey, I use feature A, B, and C, but you forget to mention E, you just simply say, hey, check out feature group ABC. And in that feature group, it contains all the information about the features used for that model. And what do I mean by like other parameters? So in machine learning use cases, naming is really important. So there could be information about like different naming strategies used, different prefixes that were added to names. That can all be captured within this. So this provides a consistent view of what went into that model at any given moment in time, and also to other teams who are completely unfamiliar with your experiment. Cool. So now that I've gone over these various consistency levels, I'll quickly go over what Twitter's stack looks like to achieve this consistency pyramid. So here's our setup. We have our various offline stores, online stores, and at the center of it, we use Feast, which is an open source feature store framework. It's SDK based, so it doesn't require any infrastructure, and it's quite modular and flexible. But we use it as our singular kind of source of truth between our online stores, as you can see here, and then our different sources of data, our offline stores, Jupyter. And it has a great set of APIs that allows us to keep everything consistent. It allows us to manage the transfer of data from offline to online stores in a very flexible way. And the challenge for us is that we have a lot of in-house systems. So we needed a solution that provided us the flexibility to basically plug in our in-house systems where we need to, but also use open source and cloud technologies where we need it. Yeah, so I'll pause here just for a second so you guys can take a look at this. Kafka for streaming, BQ is what we use for offline store, Jupyter for offline joining for experimental use cases, Manhattan's in-house database, and we use Feast serving.
David, what version of Feast are you using? Because that came up earlier with Salesforce. So that many people will probably ask this in the chat, but just to.
Yeah, we use V12 right now, V0.12, and we're upgrading to, I think the latest is 0.14. Yeah, everything post 0.10, including 0.10, is SDK based. Let's see, cool. And I wanted to quickly talk about the Feast provider abstraction to give people a sense of how we could kind of combine our custom on-prem stuff with more standard components. So the feast provider is kind of the it's kind of the connector of or the component, the command component that allows Feast Core to interact with the various online stores and offline stores. And the provider is really flexible, and it's kind of why we think it worked well for us. So it has a reference to the online store connector, a reference to offline store connector, and logic to transfer data from the offline store to online store. And for the online store, we use both an in-house database, Manhattan, and also CRDB. So for Manhattan, it has to be completely custom because it's in-house, but because we are able to just implement the class and then have the reference here to it, it works well with us. For the CRDB online store interface, we also implemented that, and we might open source it in the future. For the offline store, we can just use what's already built by the community, which is the BigQuery offline store implementation. And then here, the logic to transfer from offline to online, this can be completely custom. So this was kind of a point of concern because we use our own technologies. Maybe we have our own setups for doing the transfer of data, our own validation checks, and we want a lot of flexibility here. And yeah, in this component, you can actually just completely customize it. And when the provider API is triggered, it just calls your custom code. So we just have like a completely custom data flow job here. All right, so that's consistency. And now for the next two sections, that's a lot shorter, so don't worry. Next, I'll talk about increasing experimental productionization velocity. So here we want to integrate well with other ML components. So we're looking at, TFX example gens to integrate well with TFX pipelines. And we're also looking at example gens to have our joined data automatically be converted into the format we want, TF examples and in tensor format. And another thing we've thought a lot about is data type consistency through the ML pipeline. This is really crucial for experimental velocity. We don't want people to have to worry about different data types and whether they're doing the conversions correctly. We have a fixed set of types that we use, and all the inputs to this pipeline are converted into those types, and they're kind of converted to the corresponding types in different formats throughout the ML pipeline. And we want to integrate with tools like Kubeflow as well. Another part of increasing experimental productionization velocity is what I call hot live updates of feature sets that services use, and corresponding on-off toggles. So the question is, do we require a redeploy for services who want to switch feature sets? The answer is no. We want them to be able to switch in and out feature sets. And for various online experiments, they can actually have on-off toggles where maybe like 3% of the traffic goes to this feature set, 5% goes to that feature set, etc. So this sort of hot swapping, it's similar to how a lot of infrastructure allows the pushing of configuration files to live services. And another way that we can increase experimental productionization velocity is just aggregating all the information via UI, model used, feature set used, which toggles are on and off, having it aggregated. And this one's huge. This one we're still struggling with, which is figuring out, Twitter is a it's a company that really focuses on data privacy. So the ease of discovering which permissions are needed for certain feature data, and then requesting that permission, and then the turnaround time for approval is really key for us. It's actually a huge friction point that we need to solve, and it's a tough problem. Similarly, the ease of capacity planning and requesting capacity. Okay, nice. So that's number 2, increased experimental velocity and productionization velocity. Number 3, shareability of features.
So you got 2 minutes left, David.
All right, sounds good. Thanks, Jim. Yeah, so here are some key points of how we think about shareability of features. Beyond just having a centralized catalog, discovery is really important, especially at bigger companies who are really ML heavy. So with, if you had like 10,000, 50,000 features, it's kind of like, it's not really helpful if you don't know which ones to use. So you have the same problem. The ultimate goal is not to have it just available to for people to use, but for people to like know or to have a good reason to use other teams' features. So the goal doesn't end at just having it centralized, but the goal ends at, are people actually using other teams' features? That's the OKR that we want to be tracking. And to do this, we want to have some system of usage tracking feature importance to kind of be able to highlight features that certain teams should use, and kind of recommend certain feature sets. Other factors, can the other team's features be relied on? We have to uphold a standard of excellence for all the data going through the feature store, deprecation process, etc. And here are some challenges we haven't figured out yet. I want to share this with all of you because I would love your thoughts on this. Feel free to ping me if you have any good thoughts on this. Big one, number 1, is how to minimize the amount of support in this two-sided marketplace of producers and consumers. We want to maximize self-serve, but we have a lot of customers, and the amount of support debt keeps accumulating and accumulating. And the more pipelines we have, the more features we have, the more we have to devote to support. And this kind of ties with the 3rd bullet point, which is what incentivizes sharing. So if you're a team that is if you're on a product team and your OKRs are tied to just improving the performance of a certain recommendation system, why do you want to have these pipelines of your data available for sharing if you have to provide support and maintain them? What incentivizes you to add more features outside of you wanting to use these features yourself? So that's something that we're trying to figure out. In the organizational structure, what sort of mechanisms can get the team to structurally have incentive to help out with supplying more features. All right, cool. That was the last slide. So
perfect.
Thank you all.
Perfect timing.
Follow me on Twitter, MaviSavvyDev. Appreciate it.